Okay, Precal people, here's your very last video of the entire year. You asked for a few problems on your final exam review, so here we go. The first three you asked for are actually 1, 2, and 3, which is not surprising because it's been a long time since we've done the trig. It says use a double angle or half angle identity to find the exact value. First of all, you will have an identity page. I have those made for you for your test date. Tangent 2x is equal to 2 tangent x over 1 minus tangent squared x. That's your identity that we're going to use. But we don't know tangent unless we know cosine, because remember, tangent's sine over cosine. But the good news is, if we know sine, we can find cosine, because cosine squared plus sine squared is 1. So I'm going to say cosine squared x plus, I'm going to go ahead and square this. If I square that number, if you square 4, you get 16, 17, and 17 squared, and that equals 1. Now what I know is the 17 and 17 squared cancel, so that's 16 seventeenths. I'm going to move it over here with the 1. 1 minus 16 seventeenths is 1 17th. I'm going to take the square root to get down to cosine. I get plus or minus, really, square root of 1, which is 1, over square root of 17, which is really plus or minus square root of 17 over 17. That's cosine. Now, notice I have a plus or minus, but I'm going to look back up here. That's in quadrant 1, which means it's positive because everything in quadrant 1 is positive. So to find my tangent, I'm going to put sine, which is this, over my cosine, which is this. And what happens immediately is those 17s cancel there. Also, after you do that, the square root of 17s cancel is just 4. So that's what tangent of x is. It's just 4. So I'm going to plug the 4 in up here. That's 2 times 4. On the bottom is 1 minus 4 squared. On the top you get 8, the bottom you get negative 15. It's answer D. Number 2, it says find sine of x over 2. That's the half angle. That's on your sheet also. And what you're going to find when you read that is you're going to see it is the square root of 1 minus cosine x over 2. So they gave me sine over here again, but I'll notice inside the identity you need cosine. So I'm going to do the same thing. Sine squared plus cosine squared is 1. So cosine squared plus sine squared, which would be 11 over 36. And I'm getting that just from squaring this up here. That equals 1. Moving that over, I get cosine squared would be 25 over 36. Take the square root, you would get plus or minus 5, 6. But here's the deal. Because that angle is in quadrant 3, I'm going to do negative this time. Negative 5, 6. I'm going to go 1 minus negative 5, 6 over 2, which, by the way, is really 1 plus 5, 6 over 2. If you want to do it this way, if I go ahead and, well, let's do this. Let's multiply everything through there by 6. That's a fraction or fraction. Multiply everything by 6. That's 6. That's 5. That's 12. My numerator is going to be square root of 11. My denominator is square root of 12. The square root of 12 is really 213. Remember how we rationalize? I'm going to move that square root of 3 to the top, make it square root of 11. Take the square root of 3 out on the bottom. 2 times 3 is 6. 33. You take the 3 to the top. 11 times 3 is 33. Sorry about that. I think I misspoke there. You should get answer A. Sorry if I messed that up. Number 3, solve for theta. I'm just going to put x. First step, I'm moving the 2 to the other side, so I get 3 tangent x equals 3. Divide both sides by 3, I get tangent is 1. Now here's the deal. Tangent is 1 where, remember tangent sine over cosine like I did up here number 1. So tangent can only equal 1 where sine and cosine have the same value. You have your unit circle if you need it. But sine and cosine have the same value at 45 degrees because it's in quadrant 1. But they also have the same value at 225 because that's quadrant 3 and they're both negative. So the answer would be 45 degrees and 225 degrees. And again, you can just use your unit circle to see where sine and cosine have the exact same value. All right, the next 3 you named are 16 to 18. Let's see what those are. 16 to there. 16 to 18, the fraction ones. Okay, so on number 16, I'm going to just factor and multiply. So if I factor the numerator, I get m plus 6 and minus 6. That's all I can factor. And down here I have m plus 6. So what happens is the m plus 6's cancel. And when I look at this factor and that factor, they are exact opposites, meaning the 6 have opposite signs, the n's have opposite signs. So I'm going to cancel opposites as long as I put a negative 1, which leaves me only negative 1 times 5n, which is negative 5n. Number 17, adding fractions together. Now, 2 ways you can do this. All right, really, that's a mixed number. Think about when you learn how to do like 2.5, like a whole number in a fraction, you did 2 times 2 plus 1 is 5, so it's really 5 halves. So I'm going to do that. I'm going to do 5 times the bottom, which is 45x minus, let's see, 5 times 72, 360, plus the top, which is 7x plus 2, and that's all over 9. I'm going to go ahead and factor that, 9 times x minus 8. That's the quickest way to go. I'm going to add the stuff I can on the numerator. That'll be 52x minus 358 all over this, which looks like it is B. And 18. 18 again is addition. What I usually do with addition is make one big fraction, and the LCD is going to be 5 times n minus 2. So what I always do is look at the fraction like that. That denominator does not have a 5, so I'm going to multiply that numerator by 5. That's pretty much what you do. So I'm saying 5 times 5n is 25n, 5 times 8 is 40, plus this denominator needs the n minus 2. So I'm going to do the 8 times the n minus 2, which would be 8n minus 16. Add my n's together, that's 33n. Negative 40 and negative 16 is negative 56 all over this, which is answer A. All right, next set. The funny thing about these problems y'all asked for, they all came in groups of 3. So now we're going, let's see, 36 to 38. Okay, 36 to 38. This is an ellipse. Now, first thing you need for the ellipse is the center. The cool thing is, notice the y's aren't changing. So what that tells me automatically is the y center is y minus 2. It's always the opposite of what's inside. And if you look down here at the foci, that kind of gives it away also. You could do midpoint formula for the vertices and do like 15 plus negative 7 is 8 divided by 2 is 4. That gives you the center. But also, they added the foci to the center. So they put 4 down there. So the center part of the x is going to be 4. So I'm going to put x minus 4 squared. Because the y, if you look at the y, no, look at the x, sorry. The x part of the center is 4, but they went all the way to 15, which is 11 away. Because they went 11 to the right, that means there had to be 11 squared down there, which is 121. Now to figure out the y, what goes under the y, remember we always talk about use what they give you. Use what they give you. Well, they gave me the foci. The foci is, the c is 6 on the square root of 2. So if I do c squared, if I square the 6 and square the square root of 2, I get 72. Equals 121 minus b squared. Just doing that in my head, b squared is going to be 49. That looks like answer A. 37. Good choice, guys. Appreciate this. Just kidding. Don't mind a bit. Found an equation of the tangent line to that graph at 2, 2. So we're going to the limit as h gets close to 0 of f of h plus 2 minus minus f of 2 all over h. My marker's gotten really thick all of a sudden. Okay, equals, again, limit as h approaches 0. Plug those stuff in, Now, if I plug in h plus 2, I get h plus 2 on the top, h plus 1 on the bottom. If I plug in an f of 2, I'm just going to get that 2 right there, and that's all over h. And I can't plug it in yet because I still have h on the bottom. So what I got to do is I got to multiply to get rid of the fraction in the fraction, multiply by the denominator, which is h plus 1. That gives me h plus 2 minus 2 times h plus 1, which would be negative 2h minus 2. And my denominator has an h and an h plus 1. Keep on going. My 2's up here are going to cancel. H and minus 2h is negative 1h over h plus 1. Now I can cancel my h's, so I get the limit as h goes to 0 of negative 1 over h plus 1. Now I can plug the 0 in, so my slope is negative 1. Now remember, that's the slope. And it said find the equation. So I'm going to go point slope here. So I'm going to go y minus 2 is negative 1 times x minus 2. Point slope form. Distribute the negative 1. Move the 2 over. There you have it. That's all you got to do on that one. All right, and then 38. 38, just a matter of factoring that thing. So e to the 2x, I'm going to break that down with e to the x and e to the x. And the reason that works is because when you multiply, you add exponents, and x plus x is 2x. All right, so that works great. Factors of 2 that give you negative 3 or negative 1 and negative 2. So I get e to the x is 2, and also e to the x is 1. And remember, to get rid of the e, we're going to do natural log of both sides. I'm going to mess here. Now the 1 I know is 0. Natural log of 2, I believe, was 0.6931. You need to double check me there again. No calculator with me. That was really smart on my part. All right, let's go to the last 3, which are going to be 40 to 45. Here we go, 43. Find the sum of this one. This is obviously geometric because they're multiplying by 3. The sum of it geometric is this formula. The first term times 1 minus r to the n power over 1 minus r. The first term I know is 1. Don't even need to put that there if you don't want to. R is 3. That's what they're multiplying by. I don't know n yet. Over 1 minus r, which is 1 minus 3. To find the n, I'm going to go back and use the other formula, which is this one for geometric. And you'll have these for your test. an, which is the last term, is 2187. The first term is 1. R is 3. So then minus 1. Now, just take your calculator and start punching in 3 to the 6, 3 to the 7, until you find out 3 to what power is 2187. Well, it's the 7th power, which means because it's the 7th power, n has to be 8 because of the n minus 1. So I'm going to put an 8 right here, and I'm going to work that out real quick, and I'm getting 3280. Now, double check yourself on the calculator. I would punch it in the numerator first and work all that out, and then just divide by -2. All right, number 44, determine whether the infinite geometric series is convergent or divergent. If it is convergent, find the sum. First of all, for it to be convergent, the r has to be between -1 and +1. Don't forget you find r, we're putting the second term over the first. If I do -1/2 over 1, it is definitely -1/2, which is good. The formula for, that means it is convergent. The formula for an infinite geometric is the first term over 1 minus r. So I'm going 1 over 1 minus -1/2, which gives me 1 over 3/2. And 1 over anything is reciprocal of the denominator, which is just 2/3. And the last one, 45, a partial sum of arithmetic is given. This is how you do arithmetic, by the way. You do n over 2, and then you do first term plus the last term. Now, what I know here, or what I don't know here, is I don't know what n is. I do know what the first term is. I do know what the last term is. What I don't know is how many terms there are. So to find that out, I'm going to do the arithmetic formula, the main arithmetic formula, which is this one. an stands for the last term, which is -0.10. a1 is first term, which is -10. n I don't know. The difference I do know, the difference is 0.1. So I'm going to take the -10 to the other side, which would give me 9.9. And over here I have n minus 1 times 0.1. So I'm going to divide both sides by 0.1, which gives me 99. Move the 1 over, it's 100. So that's 100 terms, believe it or not, in there. So I'm going to work out that real quick on my calculator. It's really 50 times -10.1. Punch that in real quick. And I'm getting -505 as long as everything's good with my phone calculators and stuff. I got my good one. Anyway, hope that helps. That's what you asked for. If you need more, please send me a text. I'll video something and send it to you individually. Also, I'll be at your test early, no matter when it is. So come by and see me if you need me. Been a great year, guys. Enjoyed it a lot. Good luck. See you. Bye.